Hi everyone, and welcome to NSX Advanced Load Balancer Operation Workshop. Today's topic, traffic flow manipulation. My name is Artem, and let's jump into it. We're going to talk about policies, network security, HTTP request, and response policies. So, policies is used to control network security, client request, or response to the client. It's configured under the Virtual Services Policies tab. We can find here our network security, HTTP request, and response policies. So, good first example would be the use of a network security policy if we want to prevent certain client to access our virtual service. So, the structure of policy is simple. We have match and we have action. So we can match certain things and then we could perform certain actions. So in this example, we are matching IP addresses and then just denying the request. And it's done on network level, meaning the network security will just do not accept SYN request. Alternatively, instead of specifying IP addresses in a match client request, we could get a IP group, which can be reused for another policies, and IP group is just a collection of IP addresses. So here we have internal IP group, which will basically list all the internal networks. In HTTP request policy, we can, for example, issue a HTTP redirect. So again, the structure is simple. We have matches and we have actions. In this match, we are looking at the path that begins with /store. And if it begins with /store, the action is send a 302 status code, which is redirect, HTTPS. In this example, we'll keep a host and just send a new path, and we'll keep query as well. We'll take a more closer look at the lab. We could also do a content switching, meaning based upon certain match, we could do a certain action, and this action is content switch. So if client goes to a /store, we'll give him a pool named store. Instead of giving client a pool, content switch has an option of a local response, which will send 200 and will give client a file. And again, we'll take a more closer look at all the available options in the policies. It's remembered to note the execution priority. When client issues a request, it goes through certain steps like SSL/TLS negotiation, WAF, and then security policy and request policy, meaning the security policy will be processed before the request policy. So if security policy drops the traffic, it will never go to request policy. Similar thing goes to a response. So when a backend pool responding back to the client, first it will process the data script and then it will process the response policy. And now let's switch to our lab to get more closer look. All right. So in our setup, we have a virtual service, which is demo VS. Let's go edit it and set up some policies. In the Virtual Services tab, we will click on Policies, and here we have our set of policies. And let's look at the network security. So UI is quite simple. To add a policy, we'll click on the plus button. We select a name, let's say set policy 1. Then again, logic is simple. We have our matches and we have our actions. Let's look at the matches. We could match client IP, for example, 1111. We could add more items and select a IP group instead of specifying IP addresses. So IP group is internal, which is just a group of internal addresses. And again, we could reuse this internal IP group for different purposes, so it would be more convenient. Also, in client IP address, we could match a country group where we will list actual country code. So instead of IP addresses, we could specify countries like Albania or whatever. And it will take this information from a GeoDB database. So it will know which country, which prefixes is assigned to which country. All right, could click save. So in this specific match, we are matching IP address, internal group, or a country. An action in network security policy is allow or deny. And then we could also do a rate limit with two options, burst size and maximum rate. Burst size will basically say the number of connections or request packets can be limited simultaneously, and rate is the maximum number of connections per second. So we could specify, I don't know, 1 million connections simultaneously or 1,000 connections per second. All right, let's look at other actions. So press cancel, add new policy, select the name, sec policy 1. You could select a port, which is self-explanatory. We could select microservice, which is more Kubernetes oriented. We won't take a look at that. And we could select IP reputation, which is basically a set of IP addresses based upon their reputation. It's getting from IP reputation database, which is downloaded through AviPulse. And we could select, for example, a botnet or phishing, which is basically a list of IP addresses that is suspected in phishing. And again, we could do allow, deny, or rate limit. So let's do an example. We could actually not specify anything in match, and it will match everything. So let's deny all the traffic. Well, before clicking save, let me issue a simple curl to our VS. Which is curl. And this is our IP address. And we'll look at the headers, and the response is 200. Okay. Let's apply the policy. So it will basically deny all traffic. All right. So it will actually not allow to deny all traffic. So let's deny a internal group. Again, this will match the internal IP group, which has all the internal addresses. Click save and issue a curl again. I didn't click a second save. Let's actually save the policies. Do the curl, and we could see this, even the SYN is being denied. So it's being denied on the TCP level. So we could either delete this rule by clicking on this trash can, or we could check the checkbox and it will be disable, it will disable or enable the rule. So let's just disable it. Click Save. Issue request, and it's coming through. It's important to note that the structure of the policies is similar to access list. So I could add a second rule. Sec rule 2. That will be allowing the internal traffic. And I'll click Save. So the first rule will deny all traffic, and second rule will permit all traffic. So it works like an ACL. As soon as the policy is matched, it will stop processing all other rules. So if I'll move this one up, I can use UI to do that. Come on. All right. No. I can move it like this. So move above the first rule. Right. So first rule will allow all traffic and second one will deny all traffic. So as soon as first rule is matched, all other rule processing is stopped. So let's try it and we'll see our traffic works. All right, and then we could enable or disable the rules. Let's just disable them for now. And delete the last one like this. All right, save. Do another query. Works, hooray. And let's move on to the next policy is HTTP security and HTTP request. They are similar in that they are processing the HTTP protocol. The difference being it has a different set of actions and matches. Well, it's similar, but actions are quite different. So HTTP security, let's look at matches. So since we're processing HTTP, we'll have more things in here. So in addition to client IP address, service port, we'll have a protocol type. So we can match HTTP or HTTPS. We could match HTTP method that being processed. So we could select option or log or any method. Then let's look at the next one, HTTP version. We could match a path. It will contain, begin with, or even we could use a regex. We can match QA. We could match headers. So, for example, this rule will be if headers if header exists, or if a header have a certain value. Next would be we could match cookie if a cookie exists or cookie contains a specific value, and we could match a host header. So let's create a security rule. So let's match protocol type HTTP and we'll close connection. Let's save it. Save it. So let's try HTTP and it resets the connection. Let's try HTTPS. Oh, we'll trust the certificates and we'll see it's pathing it through. Let's take a look at more actions that we could do. So first we can allow, we can close connection. We could check with ICAP, which is a third-party HTTP verifier. We could also rate limit, which is a bit different from network security. There's two options, count and period. Count is a number of connections that allowed per specific limit per period, and then we're specifying a period itself. So we could say we'll allow 1000 connections in 1 second. And rate limiter actions could be report only, which will just signal the log that, hey, we exceeded the amount of connections. We could close connections. We could send a local response with a status code and a file attached to it. Or we could issue a redirect. All right. So the difference being between network security and HTTP security is network is processing the network layer. So if we'll deny traffic on network security policy, it will not accept a SYN. And if we'll deny traffic on HTTP security policy, it will process this TCP layer and resets the connection on a HTTP level. So as seeing this rule will match protocol HTTP and just close the connection. Again, let's test. HTTPS works. HTTP does not. Okay, let's move to HTTP request, which will have actually the same options of matches, but it will have a different actions. So let's look at the actions. In HTTP request, we could issue a redirect. We could select protocol. We could change a port. We will select a status code 302. We could change the host, change the path, or keep them. And we could keep or delete the query. We can rewrite a specific URL, and we can do a content switch, meaning that based upon certain matches, we can forward client request to a pool group, or send a local response with a status code, and we could attach a file into it. So let's do a simple rule. Let's name it request rule 1. We can match an internal IP address, and then we could modify a header. We can remove header, add header, and replace the header. Let's just add a header. Let's say request 1 will equal ABC, and save it. So this rule will match client IP address and just add a header. And let's save it and issue a test query. Oh, it's still blocking it. So I'm going to go with HTTPS. Query is gone through. And let's look at the logs. Oh, actually, no, to filter the logs better, we'll match, we'll issue a request to path ABC. All right, it's not found, but nonetheless, we could search for it in the logs of our virtual service. And we could look at the headers. And here we could see our policy actually inserted a header, header 1 ABC as per policy. But what if we want to insert multiple headers using multiple policies? We could add another rule. Let's say request rule 2 will match, let's say this time will match protocol type HTTPS, and we'll modify header. Let's add let's say header 2 will equal ABC. So now we'll have two rules. First one will match IP address and add header 1, and second one will match protocol and add header 2. But as we remember, when the first rule is being processed, all other rules are being ignored basically. So it's an ACL-like structure. When first rule is matched, all the other are being ignored. Let's save it. Try it again, and let's check the logs. We'll see that again, only one header is being added. Let's go ahead and disable the first rule. Let's see if second header is being added. All right. Let's refresh the logs. And here we'll see the second header is being added. So how can we go around it if we want to add two headers simultaneously with two different rules? So the only option would be to assign two different policies. But it's not really possible in the UI, so we have to go to CLI and create HTTP policy and then attach it to a virtual service. So let's just do that. We're going to shell. Here we could actually show our virtual service. And we'll see a reference to HTTP policy as well as network security policy. And we can create a new HTTP policy. Let's say HTTP policy 2. Save. Then configure our virtual service. Index 2 and reference our newly created policy. We'll hit save. Save again. And let's go in and look what kind of effect that it has. And now we are having a new menu, which is HTTP policy set. So this virtual service will have two HTTP policies attached to it, 1 and 2. And it will basically process both of them at the same time. So it will cancel out the ACL rule. So let's enable this. First header, save. Then we'll go to a second policy and add a second header. So we'll match protocol HTTP and we'll add a header. Header 2 of value ABC and save it. So now we have two policies with two rules and they will be processed at the same time, as opposed to having these two rules in the same policy, which will be not processed because it's ACL-like structure. As soon as rule is matched, all the other rules are being stopped, are not being processed anymore. So let's save it. Let's issue our curl. And let's check the logs if we have two headers. All right. Let's view the headers. And it's not there. So let's troubleshoot a little bit. Policies. The first rule, client IP, will add first header, and the second policy will match protocol HTTP instead of HTTPS. And I was issuing an HTTP query. So let's change this to HTTPS. Do another curl. And let's check the logs. Here we'll look at the headers and we have our two headers, request 1 and header 2 equals ABC. So this can be only achieved through the CLI. We'll create a second policy, we'll attach it to virtual service, and we could have multiple policies under the one virtual service. All right, let's move to the next step, which is HTTP response, which will basically change the HTTP behavior when backend server or a pool responds to the client. The matches is similar to HTTP request and security policies. In exception of HTTP status, which is actual response from the client, from the backend server, and response header. So let's match the. Let's see what we can match. Let's match HTTP status, because URI ABC is not found, which is 404. So let's match if the response from a backend server is 404, can in the response policies modify header or rewrite the location header. So let's just add another header. Let's call it response 1. And value is still going to be ABC. And save it. Let's do another curl. Already here we could see we are getting response header, but let's check the logs anyway. Let's view the headers. And headers sent to server consist of our request and headers because of the policies, and in the response headers sent to client, we could see our response header, all according to our policy. right? It's important to know to look at the logs. We should enable non-significant logs under the virtual service, analytics tab, non-significant logs. Otherwise, logs without any errors just won't be displayed in your VS logs. And don't forget to check this little checkbox to show non-significant logs. Otherwise, it just won't be there. All right, that's all I have for today. And next time we're going to talk about data scripts. Have a nice day and goodbye.